AP testing, I'm guessing. But we got a couple things to look at today. We have our 2.5 quiz next class, so that would be Thursday. And so we started looking at that for the first time last time. And part of what we did was a worksheet. And the worksheet is what your quiz will look most like. But then we also did the book assignment, which was 112. And there was a few questions I had you guys do at the end of that class, and we didn't have time to go over each of them without rushing. So I told you that we could look at those together today because there would be time for that. So I need you to get out your book assignment 112 and see of these last questions which ones you're going to need to pay attention to. So I'll go over all of them quickly, and then I can go over any of them that I need to slower and more in depth. And then for some extra practice, I'm giving you the test review early. So the first 3 pages is stuff that you learned in Algebra 2, and I hope that you remember, and you are more than welcome to get a jump start on that. But the reason why I'm giving it to you today is so that you could do the back page, questions 21 through 28, because those are questions from section 2.5. So doing them today will get part of your test review done, which will make less work later, and it gets you in a little bit more practice before your quiz on Thursday. Okay, so it looks like the first question that I left y'all on was question 33. So again, almost all of these are odd questions, so hopefully you've checked your answers already. And again, you don't have to follow and pay attention to the ones that you know you're good on. Feel free to do a question from your worksheet. But for those of you that needed to see question 33, this was one that said, part A, write out the possible rational zero test. So that's the P over Q list. That's what I have in red. Part B was to sketch the graph. And so I did that in my calculator. Now our quiz will be no calculator, so you can't rely on the calculator to get the answers, but we could maybe give you a graph and then ask you to approach questions the same way. And then this one was pretty easy in that to get the 3 answers, because it was a 3rd degree, all 3 of them were nice whole numbers on the x-axis. So 2, -1, and -2. Which was part C. You find all of the real zeros, and then indirectly they're wanting you to see that all of these zeros were in the list of possible rational zeros. 2 is in the list, -1's in the list, and -2's in the list. Okay, anything more specific about 33? Okay. Then check to see if 37 is one you needed help with. Pretty much the same question type. Part A, make the P over Q list. Part B, sketch a graph. So I did this with my calculator. And then part C, find all of the real solutions. So I saw 4 x-intercepts, so I knew all 4 of them were real. And then again, we got lucky. This doesn't always happen, but we got lucky in that all 4 of the x-intercepts were nice whole numbers. 4, 2, 1, and -1/2. I mean, I guess -1/2 is not the nicest whole number, but it was also a pretty easy guess. So, where your function equals 0 is what we call zeros, and where that shows up on a graph is x-intercepts. So, any questions about that one? Okay, then 41 and 43, we did one of these on the worksheet together as an example, but then you practice these 2 on your own. So I gave you 2 zeros, 1 and 5i. You had to know that there was a 3rd zero that existed, because imaginary zeros always come in conjugate pairs. So I think I said this last class, but that's not a Fayetteville High School thing, that's just a mathematics thing, so you started to see this in several questions. So I had to include this 0 that they didn't tell me, change each 0 into factors by doing x minus each of them, And then when you multiply all that mess together carefully, you end up with a polynomial function with real number coefficients. So you don't have to know too much for this question type, but there's a lot of multiplication, so you do have to be careful. And you do have to know that I squared is -1 for all of those. Okay, 43 was the same type, but a little bit longer. It gave you 3 zeros. One of them was an imaginary zero, so his conjugate pair had to be a 0 as well. I did x minus each of these and distributed the minus to get the factors. Multiplied these two together with FOIL, distributed these two. Then I had a quadratic times a quadratic, distributed those. Again, lots and lots of multiplication. And then in the end, I ended up with this polynomial function with real coefficient numbers. So very good practice as far as multiplication goes. So look over 41 and 43. Make sure that you guys don't have something you'd like to ask about that. Okay, we good there? Okay. Okay, and then 59 and 60 were the same question types, and I would say these were probably the hardest questions, but we had one like this on our worksheet that we did before the book assignment, so you can see it is something that we expect you to be able to do. And I really enjoy these questions, bless you, because it pulls together all of these different skills, almost all of them. So knowing that imaginary zeros come in conjugate pairs gets you from the 1 0 that was given to you to a second 0. If you know zeros, you can change them to factors by doing x minus each one and distribute the minus. Instead of trying to divide by these two really ugly factors, we can multiply them together, which kind of looks like the last question, and that makes it look like a nicer quadratic. So these two things multiplied together are the same as x squared minus 2x plus 3. And then this understanding that if you divide out some of your zeros, you divide out some of your factors, you can take the original polynomial, which was a 4th degree. If you divide out a quadratic, it leaves behind a quadratic. So it's like a hidden quadratic, and if you can find that, you can factor it and or do quadratic formula. And if you've got the factors, just where each factor equals 0 will give you the other two zeros. So again, you had to know there was 4 answers. You had to know imaginary zeros come in conjugate pairs. You have to know how to change zeros into factors. You have to be able to multiply factors, ugly factors like this together. You have to know why you need long division here and not synthetic division, and then know what to do with this answer, how this is supposed to help you get the last two things. So it's really trying to connect a lot of different of these otherwise seemingly random algebra skills. Okay, and then 60 was along the same lines. They gave you an imaginary zero. His conjugate has to be another one. I changed both of those to factors by doing x minus each of those and distributing the minus, so that I didn't have to divide these two out, which would be insanely messy. I multiplied those together, and these two multiplied together are the same thing as x squared plus 4x plus 7. So dividing by that is like dividing out both of these factors that I knew should go into it evenly. And by the way, when I wrote this out in my 0 hour yesterday, like I had an arithmetic mistake or two in here. But remember, factors means that it should divide into it evenly. So I knew I was supposed to have a remainder of 0 in this instant, so I knew I had a mistake, and I at least fixed it before I just kept on going. But if you take a 4th degree and divide out a quadratic, it's going to leave behind the other quadratic, which I was then able to factor, and then set each factor equal to 0 and solve. So 59 and 60, similar question types. And obviously we're not going to put like 5 of these on your quiz because they're pretty time consuming, but you should expect 1 or 2. So don't be dismissive and think that that's too much for a quiz. That is certainly fair game. So, questions from 59 or 60.
Can you go over them slowly? Because like I'm lost just trying to look at your, or like working out actually not having the part in.
Sure. So you need to tell me what part that you went different on though.
Okay.
So I think you just started off with okay. I think you just started off with this 1 0. Is that correct?
Yeah.
Okay. So you have to know that imaginary zeros come in conjugate pairs. So that's the only way for you to move forward. If you don't know that, you're stuck at the beginning. That's super important. Okay, I really want to divide out this 0 to get it down to a third degree, and then divide out this 0 to get it down to a quadratic. But I can't synthetically divide by these. They're not in the right format. And even if I could, you're going to have i's all over the place until you're done dividing both of them. So a nicer way to divide both of these out at the same time is to figure out what their factors would be. So do x minus each one, distribute the minus. So this guy 0 would look like this as a factor, and this guy 0 would look like this as a factor. And I'm still kind of in the same boat. I don't want to divide by this. This is too messy. But if I multiply all this together, it's going to be a pretty nice looking quadratic. So you've got to take x times all three of these to get 3 terms. And then -1 times all 3 of them. And then distribute the I squared of 2 to all 3 of them. So positive times a negative would be negative, I times I would be I squared, and square root of 2 times square root of 2 would be 2. And even though this looks worse, it should only look like that for one step, because every time all of the I stuff should clean up. So we've got plus xi square root of 2 minus xi square root of 2, so those add to 0. We've got an I square root of 2 minus an I square root of 2, so those add up to 0. We've got an x squared. We've got a minus x and a minus x, which makes minus 2x. And then this part you got to be really careful with. If you glance at this too fast, you're going to get the wrong number here. You've got a -1 from this negative. I squared is -1, and you've got a 2. -1 times -1 times 2, so all of this is like a plus 2. So you can combine that with the plus 1 and get plus 3. So instead of saying this, you can say this, because these are equivalent. They're the same thing. So this is much easier to divide out, but I can't do synthetic division because it's quadratic, so I have to do long division. And so I realized that this quadratic should be a factor, so it should divide into this evenly. When I do long division, I better get a remainder of 0 or something's wrong. But more importantly, you got to understand why you're doing this to know like how this is supposed to be useful. When I take this 4th degree, divide out this quadratic, it's going to leave behind a quadratic, and this quadratic is going to help me figure out the last 2 zeros like we would normally do. So you go through the long division process. And as I said, 0 hour yesterday. If you're not careful, it is very easy to make an arithmetic mistake. So I will try to keep up with these signs the best that I can. Looks like next we would need a -4x, because that would give us -4x cubed, an 8x squared, and a -12x.
Was it not plus
What plus 2?
Like at the end, you know what you're dividing by, because I thought we got +2 for the last number.
But this is a constant.
Okay.
Okay, so this plus 2 combined with this plus 1 and got a plus 3.
Okay.
If you're talking about the x's,
That's what I was talking about.
okay. Yeah, there's still a plus 1. Now, obviously you don't have to do this, and I don't know if I gave you guys this tip or not, but one thing that you may have noticed that I do, when I've got a bunch of terms like this, like 9 terms, one of the best things that I think you can do to kind of reduce some just oversight is underline things as you use them. So like I have x squared, that's it. Then I can't read this anymore. There we go. I have an x squared, so if you underline it after you consider it, and then a minus x becomes a minus 2x. This stuff canceled out with this stuff, this canceled out with this stuff. And if you just underline all of this stuff, then in the end, it's a lot more obvious what things you haven't used. I haven't used this plus 2, and I haven't used this plus 1, so that's a plus 3. Otherwise, it's very easy to lose a term there. Okay, I lost my train of thought here, but looks like I was ready to switch the signs and add. Okay, and then if we keep going, this is looking good, because the next piece would need to be 3, which would give me 3x squared minus 6x plus 9. And then as soon as you change the signs and add, you get a remainder of 0, which again should happen here, because if these were really zeros and those were really its factors and I really didn't mess up multiplying those, then it should divide into it evenly. But really all of that work was to expose this hidden quadratic. And so if you need the other 2 factors, you can factor it. If you need the other 2 zeros, just tell where those factors equal to 0. And so that's where all 4 came from. Okay, did you see what you needed from that one?
Yeah, I just messed up on my that.
In this part?
Yeah.
Yeah. But then when you did the long division, weren't you then having issues getting it to
Yeah.
go into it?
Figure it out.
Yeah. So when that happens, again, it doesn't tell you what you did wrong. It either means that you're doing something with long division wrong, or maybe you did something wrong here, but at least you've got some kind of a check when you're near the end of the question. So, okay. Are you ready for number 62?
Yes.
Okay. So pretty much the same thought process, just different numbers and a second practice question. Okay. There's got to be a faster way to delete all this. Okay, maybe not. Okay. So, most important thing with 60, just like 59, is knowing the second zero, because if you don't know a second zero, then you're pretty much stuck at the beginning. But imaginary zeros that have an I in there have to come in conjugate pairs. They always come that way. I would like to divide these two out of this to get it from a fourth degree down to a second degree, because if I can get it down to a second degree, even if I have to use quadratic formula, at least I know I can get the last two. But realistically, the only way you're going to divide out both of these at the same time is if you change them to factors by doing x minus each one and distributing the minus, and then multiplying these two together so that they look a little bit nicer. So you need to do x times all three, then positive 2 times all three, and then finally negative I squared of 3 times all three. And then this last one, be extra careful because there's a lot of stuff here. Negative times a positive is negative. I times I would be I squared, and square root of 3 times square root of 3 would be square root of 9, but that reduces to 3. And so, well, you got 3 terms times 3 terms, so there should be 9 terms, so that's a quick little check. If you don't have 9 terms, then there's definitely something wrong. But also, all of the I stuff should cancel out and go away. So, plus xi square root of 3 minus xi square root of 3 plus 2i square root of 3 minus 2i square root of 3. I can see an x squared that doesn't look like he has anyone to combine with. A plus 2x and a plus 2x, that makes a plus 4x. And then the last two would be these two. So just like the last question, if you do this too quickly, I'd say it's 50-50 whether you're going to guess this correct. You've got a negative times I squared, and I squared is negative 1 times a 3. So negative 1 times negative 1 times positive 3, all of that is like a plus 3. 3 plus 4 becomes plus 7. So just to be clear, this stuff, these two really ugly factors are the exact same as this quadratic. And this quadratic is a lot nicer to look at and certainly a lot nicer to divide by. Okay, so I have known I wanted to divide this out because it's going to let me see the other quadratic hidden inside this fourth degree, and from that other quadratic I can get the last two answers. Now, since both of these are supposed to be its factors, once again, I know that I'm supposed to have a remainder of 0, so I've got a little bit of a check before we pick our answers and move on. So start the long division process. Change the signs and add. Change the signs and add. And in the end, change the signs and add. I got a remainder of 0, so I'm feeling really confident about my work. But again, I'm just as susceptible to making careless mistakes in here. That happened to me just yesterday. So obviously there's no hurry. But if you don't get a remainder of 0, either you've got a mistake in your long division or a mistake in your multiplying the factors together, or maybe setting up your factors. But now that I know the hidden quadratic was x squared minus 3x plus 2. Ideally, I solve it with factoring, but even if I had to do quadratic formula, at least I would get the answer. So factor it, set each factor equal to 0. It looks like the other two zeros were 1 and 2. Now, even though this is not a calculus question, we're not doing any calculus in here, and we don't do this type of problem in calculus, it does remind me quite a bit of calculus, because calculus is one of the first times where you guys get to really kind of see, like, hey, there's this random algebra thing you learned, and this random algebra thing you learned, and this random algebra thing you learned, and then throw them all together in a question, and all of a sudden you can do something new with them. And that's how I kind of feel about this one. Okay, any specifics about the last one there? Of course, if you feel weak on any of these, it's always a good idea to force yourself to re-practice them on a separate sheet of paper and make sure that you feel better about them your second or your third attempt. Okay, then let me give you some time to start on that back page of the test review. So questions 21 through 28 would all be great questions for the quiz as well. So you've got some class time to get that done, and then when your test rolls around, that will be that much less you have to worry about getting done. So let me give you some time to start on that, and then I will jump in and see what kind of help I can give in about 15 minutes or so, once you have had time to try some of them. It's been almost 15 minutes. So from this back page, is there any of these questions you've tried yet that are standing out to you as being more difficult? I'm sorry, which one? 26, sure. So what I would suggest on 26 is go ahead and just find the zeros first. Now, how to find the zeros in this question type, this is where you'll need as much practice as possible, and I'm asking you to do the back page of this worksheet. It just depends. And if I had a calculator, I would graph it and hope to see all 4 on the x-intercept. If sometimes you're given a hint, like, hey, 3 is a 0, or x minus 3 is a factor. Neither one of those things happened on this question. So in that case, this would be like most of the questions on the front page of our worksheet last class, where to find the zeros, if we're not giving you a hint, and we're not giving you a graph, and we're not giving you a calculator, and it's not a quadratic for quadratic formula, then it's going to have to factor. And when you factor, you really would like to factor completely. So even after you factor the trinomial, which by the way you could do with product sum method, the 2 quadratics factor as difference of 2 squares. So it looks like the zeros, now that I've got the factors, are -1, +1, +1 again, and -1 again. Now last week, my 5th period class had a question about, well, if -1's on there twice, do I need to keep it twice? And if 1's on there twice, do I need to keep it twice? And the answer is yes, because if you only keep one of each of these, it's going to be like it's a quadratic. If you say there's 2 zeros, it's a quadratic. This is supposed to be a 4th degree, so we have to keep up with all 4, even duplicates. Now, the part of this type of question that seems to mess students up the most, and we tend to put this on the test and the quiz, so make sure you guys are familiar with directions. When it says product, you need to know that that means multiplication. Linear factors. Linear means that the exponent on x is 1. So like this is not good because these are quadratic factors. And then it wants them as factors. So really, I guess I could have done that up here. But if you can find the zeros, you could do x minus each one to get his factors. And don't separate them with commas. Separate them with multiplication signs, so it's product. And these are linear because they're all x to the first, and they're factors. So that's what we're looking for as an answer. But I'd say 95% of what messes students up with this is not knowing what the directions are asking for. Okay, was that enough? Okay, so anybody else going to ask about 26? Have something else about it before it's gone? Now, I will also say that every year I do emphasize those directions, and then still every year, that's one of the more missed questions. Even though I can see in previous work that students can do this stuff, a lot of times y'all just don't, I don't know. Put a star by that and make sure you review it so that you're not caught off guard by the directions. I guess that's the only hint I can give you. Okay, others you've tried on this back page? Again, the first 3 pages you may recognize, and you may even remember how to do all of it, and that's great. But that stuff's not going to be on Thursday's quiz. We're going to reteach that stuff over a couple class periods. So it's really just this back page from this handout at least. Anything else you got ready? Okay. Well, we still got about 35 minutes, so I can set another timer here. So about 15 more minutes from now, that will still give us 20 minutes to go over any questions you may have found. But I am going to take up 2 assignments. Both of those are already open in Google Classroom, so if you want to turn those in early, that is certainly encouraged. To review, the worksheet we did last class is what your quiz will look most like. But that worksheet also didn't ask anything about the rational zero test. We don't usually have it on there because usually students are pretty familiar with it from Algebra 2. Sounds like y'all just didn't do it much in Algebra 2, if you did it at all. So that would also be fair game. So I would look at the worksheet we did last class, the book questions we did last class. Those are the 2 assignments I would pick up, and then the back page of this. If you're comfortable with any of those question types, then you should feel good about the quiz. Okay, I'll bug you in 15 minutes for more questions.
Do you happen to already have the quizzes printed out?
I don't.
Okay. I was gonna see if I could take it, because I won't be here.
I could try to have it by advisory.
I'm leaving midway through advisors, so I don't know
Oh.
if that would work, yeah.
Yeah, it would be too long for you to try to do right now anyway.
Okay,
So.
thank you. Is this the sign you're talking about? Isn't holes just when it cancels and then? I mean, I'm sure I can.
So x-centers, so we'll be looking at rational functions, which is when you have a function that's a fraction.
Yes.
So if you have a number that makes just the numerator 0, you get an x-intercept. If you get a number that makes just the denominator 0, it's a vertical asymptote.
Okay.
And if there's a number that makes both 0, it's a hole.
Okay.
So it's got to be, can't be more than one of those at a time.
Okay. you factor out an x,
Uh-huh.
is that like is that a vertical asymptote?
Because
So
if
will it be 0? Okay.
because if x was 0, then that whole denominator would be 0.
Thank you.
Okay, so that has been another 15. So last chance. Anything else on the back of this worksheet? Okay, so as I said earlier, there's 2 assignments I'll be picking up for homework grades. Both of those are opened up in Google Classroom already, so if you've not turned those in, you might go ahead and do that. Otherwise, as always, I will expect them to be turned in before we start the quiz on Thursday. And would be a good idea to make a reminder in your planner or something about the quiz as well.